Today in math, we'll be discussing the derivative of the product of three or more functions. Let's say we have three functions, f of x, g of x, and h of x, and we define some other function y of x to equal the product of these three functions, namely y is equal to f times g times h. Now what we want to figure out is what's the derivative of y of x, namely what is dy over dx? What is this equal to? One way we can think about it is instead of thinking of y of x in terms of the product of three functions, we can think of it as the product of two functions. So let's define another function. We'll call it j of x. We'll say j of x is equal to f of x times g of x. Then we can rewrite our equation for y to be y of x is equal to g of x times h of x. Since we define that j of x would be equal to f of x times g of x. So then, we know how to take the derivative of the product of two functions. Namely, we can write the derivative of y of x to be j of x times the derivative of h of x plus h of x times the derivative of j of x. So we can rewrite that to be equal to j of x we know is f of x times g of x, and we know that the derivative of h of x is just dh over dx. And we have h of x times the derivative of j of x, and we define j of x as f of x times g of x. So now we're dealing with the derivative of j of x. Let me rewrite that. But only on one side. So once again, we have our front term remains the same, and we can expand the derivative of j of x, or the derivative of f times g of x, to be equal to f of x times the derivative of g of x plus g of x times the derivative of f of x. And when we expand this whole thing out, we find that the derivative of y with respect to x is equal to the first two functions times the derivative of the last plus the first and last times the derivative of the middle one and our final combination, namely g of x times h of x times the derivative of f of x, namely df over dx. So when we're trying to find the derivative of the product of three functions, we simply treated it like the product of two functions. And the same method is not specific to the product of three functions. It can be extended to multiple functions. So once again, we have f of x and g of x, and we define y of x to equal the product of f of x and g of x. But now, we can define f of x to equal the product of two other functions, or three other functions, or as many functions as we want, and same thing goes for g of x. So when we say y of x is equal to f of x times g of x, in reality that could be the product of 10 functions, or 12 functions, or as many functions as how f of x and g of x themselves are defined. But we can always use what we know about finding the derivative of the product of two functions in order to find the derivative of y. So we can always find dy over dx as long as we treat it with the idea that it's a product of two functions. All we have to do is define what the two functions are and then keep taking on derivatives. So that's how we take the derivative of the product of three or more functions.